Welcome to this training video. In this training video, I will provide an introduction to communication systems and networking. Actually, it will be communication systems and communications technologies in this first part. In second part and third part, I may come to the networking part, but in this particular video, the focus will be on communication systems and communications technologies. So, this is Said Ahmed. I provide software development and web development consultancy under just etc. technologies. So this is my company website and this is my personal website. This is my email address. I provide free training videos on the website, like here in Bengali and here in English. And if you have any questions related to computing or about this training video, the topics discussed in this training video, you can post your concerns here. Okay, communication system. What is the communication system? Communication system actually transmits or communicates data or information between computer to computer or computer to other devices. So yes, so communication system, it's some sort of data, picture, information, voice, from multimedia, whatever it is, will be transferred from one computer to another computer, or from one computer to other devices. So this communication, it can happen through telephone line, fiber optic cable, or microwave. These are the communication media, transmission media. This data will be transmitted through this media. This is an example communication system, just the point-to-point communication link and PPP network. We used dial-up connection for internet connectivity a while back. So this can be an example of the communication system. In this example, you can see that the data from a computer is transferred to a modem. The modem converts that data or information into a analog signal. This is the digital signal, and this is the analog signal. It passes over the public telephone network, and then it receives the modem. In the receiving end, it converts this analog signal into digital signal, and it is fed to this computer. So data is transferred from computer to computer using modem and telephone lines. So I just wrote this example: computer to computer through modem uses telephone system. Information from the source computer is converted to analog signal and passed over telephone line. Modem does the conversion work. In the receiving end, modem again converts analog signal to digital signal and supplies to the destination computer. Concepts behind data communications. Here I will discuss some concepts related to data communications. Elements of data communication system. Yes, I think the source computer, I think in the previous example, you can see this computer, this is the source from where the data or information is originated. Transmitter actually transmits the data or information to the communication channel. So the modem will be the transmitter. Communication channel or medium, there's a telephone line. Receiver, here the receiver is the modem, and this is the destination of the communication system. Destination is the computer. And data transmission speed or bandwidth. Then there are three different bands: narrowband, voice band, and broadband. Narrowband, slow speed, low speed, 45 to 300 bit per second. An example will be telegraph communications. Voice band, it's actually to transfer the voice, and the transfer speed is 9600 bit per second. The traditional telephone line, computer to printer communications, in this case we use this voice band. Broadband, high speed, minimum speed is 1 megabit per second. For broadband communication, we can use coaxial cable, optical fiber, also satellite communications and microwave communications. Those are broadband communications. particularly satellite communication. This is also microwave communications just through the satellite. So methods of data transmission. When data transmits from one source to another destination, how the data is transmitted. I think it's three different ways: asynchronous, synchronous, and asynchronous. Asynchronous transmission. In this case, data is transmitted at irregular intervals. Data is not transmitted at regular intervals. That does mean the data is transmitted irregular interval, and data is not transmitted as a steady stream, and data is not transmitted as a block. And there is no external clock signal in this kind of asynchronous transmission. I think there is no clock signal and there is no synchronization between the sender and the receiver. And usually data is transmitted as character by character, and the delay between one character and the other character transmission, it is undefined. So keyboard to complete communication, it is asynchronous communication. When you press one character and when you will press the next character, it is a little bit undefined. So it is asynchronous transmission. The transmission is used for communications over the telephone lines. Exception are into RS-232 actually, RS-232. In this case, I think it still is asynchronous transmission, but it uses some sort of clock signal. Synchronous transmission, in this case, data is transmitted as a block. A stream of data is sent at once. Most computer network protocols, such as Ethernet, SONET, token ring, all use synchronous transmission methods. Data transfer method, and definitely a clock signal will be used here to synchronize the sender and receiver to keep them in step, so that data transmission becomes successful without any error, and whatever the sender sends, the receiver can receive them appropriately. So here you can see a continuous stream of data signals is accompanied by timing signals generated by an external clock to ensure that the transmitter and the receiver are in step, synchronized with one another. Isochronous transmission, it's a form of synchronous transmission, but here the delay between two blocks is minimized. In synchronous transmission, data transmission delay is kept to be the minimum between two blocks used in real-time data transfers. Just real-time game relay, those type of things. Data transmission mode, based on the direction of the data flow, data transmission mode can be of three types: simplex, half duplex, and full duplex. In simplex, data is transferred into one direction, always into one direction, never in another direction. Just like radio and TV, it's just always one-way communication. Simplex. Now half duplex. Half duplex, data can be transmitted in both ways, but at one moment data will be transmitted into one direction. So if both the communication has to happen when one device stops transmitting, the another device has to transmit. Both the transmission possible, but at one moment only in one direction. For example, walkie-talkie. Full duplex transmission, data can be transmitted in the both ways at the same time, just telephone and mobile. This is just another one. So anyway, so on mobile you can see that there is a continuous data transfer in both directions. Actually, I think we can use separate frequencies for sending to different directions so that they will not interfere. Data transmission mode, unicast, one-to-one. One sender sends the data to one destination. Broadcast, the data is sent to multiple, not really multiple, all of them. Just radio transmission, TV transmission, those are broadcast transmission. The station is sending the data to all of them. multicast. In this transmission, the data is transmitted to a group of destination, not to all of the destination, but a group of the selected group. Data communication medium, it can be wired, just coaxial, twisted pair, fiber optic. Coaxial cable TV system, those usually use coaxial, twisted pair, telephone line connections, those are twisted pair. Fiber optic, it's just optical communications. It is based on glass or high quality plastic, and data is transmitted through wavelength division multiplexing kind of thing. Wireless medium, it can be radio, it can be microwave. Yeah, it can be radio and it can be microwave. Radio, I think the radio frequency is 10 kilohertz to 1 gigahertz, speed 24 kilobit per second, and it can penetrate walls. So for low speed communications, radio signals usually used in cellular networks. And for the radio frequency range, some part are control and some are open. In control part, they have to be permitted by the government to be used by some company or carrier. Open, anyone can use this. Microwave communication, it can be terrestrial and it can be satellite communications. Terrestrial, you can see it has to be line of sight, there should not be any obstacles, and it cannot penetrate walls or anything. It is very narrow, they have to be line of sight. Satellite microwave, this is a transmitter using microwave signal, and these are the receivers in different parts of the world. You can see it. Satellite communication is data is communicated from one part of the world to the another part. There are some ground station, hub stations, and there are some concepts. And this is another picture. So microwave frequency range is 300 megahertz to 300 gigahertz. The transfer speed 1 gigabit per second. But some RF engineering mentions that the practical usable microwave is 1 gigahertz to 100 gigahertz. Microwave can transmit data, voice, picture, and usually uses transmitter and receiver, just as you saw in the picture. So terrestrial uses line of sight, should not be any block between transmitter and receiver, all those things. Satellite can be lower bit satellite and geosynchronous satellite. Lower bit satellite, they are not significantly high from the ground of the world, and they are slow and they cannot cover the whole world. And they can use some sort of ground stations or some sort of amplifications to cover a larger areas. And geosynchronous satellite, they move with the speed of the world and they can reach the whole world. Geosynchronous satellites. What are the components of satellite? Receiver, the microwave signal receiver antenna, transmitter and transmitter antenna, transmitting to the world, to the ground. Transmitter antenna transmit the signal to the ground. And sometimes satellites also have transponder to amplify the signals. Wi-Fi is actually for wireless LAN. It uses the radio wave and you can use it to create the wireless LAN communications. Wi-Fi can help you to connect to the internet, and as I also told, it can also used to create wireless LANs on computers. A popular technology that allows an electronic device to exchange data or connect to the internet wirelessly using radio waves. Okay, actually, Wi-Fi technically means the IEEE 82.11 standard. Any products, any wireless products that that are compatible with this standard are called Wi-Fi. But in general, all the products used to create the wireless LANs are usually Wi-Fi compatible, Wi-Fi alien certified. So in general, Wi-Fi is used as a synonym for wireless LAN. Advantages of Wi-Fi. You can use Wi-Fi where using cable is difficult. You can get wireless LAN and Wi-Fi when cable is difficult, or in the building where using cable is difficult. Most laptops have Wi-Fi, so you can easily connect to Wi-Fi. Hotspots usually used in coffee shops in North America. Disadvantage: data transfer is slow and coverage is limited. The wireless LAN cannot cover much area. Data security is an issue, but I think some protocols like WP, WPA, WPA2, those are implemented for data security. Probably WP is easy to break, and WPA, WPA2 are harder to break, but it's not 100% secure yet. And network security is also an issue, but technologies are arriving to recover security issues. WIMAX, it is a standard-based technology to provide the last mile broadband internet access, and it can be used as an alternative to cable and DSL. It can provide internet access to remote areas. The primary advantage is it can provide broadband, that means high speed. As you can see, these are WIMAX stations providing internet access to the remote areas. WIMAX speed, as of June 2005, the speed is 30 to 40 megabit per second. As of 2011, the speed is 1 gigabit per second. Sometimes WIMAX is referred to as Wi-Fi on steroids. It can be used in many applications like broadband connections, as I told, cellular backhaul, hotspots. It is similar to Wi-Fi, but it can enable users at much greater distances. WIMAX uses, you can see, for potential applications. Portable mobile broadband is mobile broadband internet connectivity. That's something very important. Across cities and countries through a variety of devices. Wireless alternative to DSL. And last mile broadband access. Can provide data telecommunication IPTV service, triple play. Source of internet connectivity as part of business continuity plan. Sometimes some business can use WIMAX as an alternative to the cable or DSL connection. Maybe when there is a problem with the DSL or cable connection, they can switch to this WIMAX and they can get the internet connection. Smart grids and metering applications can utilize WIMAX. In certain applications, it can compete with microwave for creating metropolitan area network, or in telecommunication systems to connect to remote areas or long distance. It can compete with microwave. Can provide internet access to remote areas. A good alternative to DSL and cable can be used in this manner, which is the same thing. Disadvantages of WIMAX. After 50 kilometers, the speed becomes less than or equals to 17 Mbps, and with increased distance, more base stations are required. Bad weather can affect the signal quality and also the speed. So some information are taken from the Wikipedia. Thank you. This is all for this training video. I will create more training videos on communication systems and networking in a short period of time. Thank you and have a good day for now.